Hello everyone. Now let's solve this mind-blowing physics problem on the board. A cyclist is freewheeling down a long straight hill. The times between passing successive kilometers post are 100 seconds and 80 seconds. Assuming its acceleration is constant, find this acceleration. Now, the times between passing successive kilometers post are 100 seconds and 80 seconds. So which means now during this time, that is during the kilometers, that is the first and second kilometers, okay, the acceleration of the cyclist, okay, freewheeling down a long hill is constant. Okay, so if this acceleration is constant, that means the value of the acceleration remains the same. It does not change. Okay, so we are asked to find this acceleration. So the first thing we need to do to be able to solve to calculate the value of a, that is acceleration, is to first recognize the fact that the times between passing successive kilometers, okay, because we know that 1 kilometer is exactly 1,000 meters. So which means that so during the first kilometer and during the second kilometer, so the times will be 100 seconds, okay, will be the time it takes the cyclist to travel during the first kilometer, and then during the second kilometer it will take 80 seconds that way. Then also we need to also find out the velocity, okay, that is the velocity at the start of the first kilometer, and then the velocity at the end of the first kilometer will now be the velocity, okay, the velocity during the second kilometer, okay. So that way then we should be able to find the value of a. All right, now here is how to solve the question. So first we need to understand that if I have t1, okay, t1 is the time taken, okay, by the cyclist to travel the first kilometers, okay, to travel the first kilometers, okay, and that time will be 100 seconds according to the question. Then t2, okay, equals time taken, okay, to travel, okay, to travel the second kilometers, okay, and the time would be 80 seconds. That'll be 80 seconds. So during the first and second kilometers, so we need to also find the what? Velocity. So let's also have V1 to be velocity, the velocity at the start, okay, at the start of the first, at the start of the first kilometer, okay. Then V2 will be the velocity at the end, okay, at the end of the first kilometers, which is the velocity, okay, the velocity, that will be the velocity during the second kilometer. So that's it. So which means if we have velocity at the end of the first kilometer, so it simply means that the equation for V2 will be V1. So V1 will be the initial velocity multiplied by plus A. Now we know that A is constant, so there's nothing like A1, A2 in this case. So because the acceleration is constant, then multiply by T1. Okay, multiply by T. So T in this case is going to be 100 seconds. Yeah, it's going to be 100 seconds. Yeah, 100 seconds. All right, so we come back to this. All right, so but now another thing we need to note is that because we have the cyclist to be freewheeling down a long straight hill, then it means that the distance will remain the same, because the time it takes the cyclist to travel the first kilometer is 1 kilometer, which will be 1,000. So if we have distance, S is the distance traveled, okay, S is the distance traveled. So that means that S will be 1,000 meters, okay. So which means so the distance during the time 100 seconds, okay, is the same as the distance when the time is 80 seconds. But they have, they'll be, we're going to use different, during 80 seconds and during, what's it called, 100 seconds, they are equal. Okay, but we can't use that to solve for A. Now, why is it that? Because we have, for during the first kilometers, we have that to be, because we are using V1 multiplied by T1 plus 1/2 of the acceleration multiplied by T1 squared. So this is 1000. Of course, their distance is 1000. Okay, not that. So their distance is 1000. Then V1, we have V1, which is unknown, then multiply by 100 plus 1/2 of A times 100 raised to the power of 2. So this will be 1000 equals to 100 V1 plus, this will be 10,000. So 10,000 divided by 2, that will be 5,000. So this will be 5,000 A. So now let's divide this by 100. So dividing by 100, we have 10 equals to, this will be V1 plus, this is 50A. And let's call this equation 1. All right. So for S subscript 80, okay, so this will be, we have also 1000 equals to, so that will be V2. So this one will be V2. So different velocity now. Okay, so V2 multiplied by 80. So we have V2 multiplied by T2, then 1/2 of AT2 squared. So that 1000 will be equals to V2 multiplied by 80, then 1/2 of A times 80 squared. So this will be 1000 equals to 80 V2, okay, plus this will be 80 squared. That will be 6400. Then 6400 divided by 2, that will be 3200. That will be 3200. Okay, let's also divide this by, let's divide this by 40. Yeah, let's divide this by 40. Divided by 40. So if you divide this by 40, okay, this will be 25, and then this will be 2V2. Okay, then plus this will be, when divided by 40, this will be 80A. Okay, so let's call this equation 2. So this is our second equation. When we divide 1000 by 40, okay, that will be 25. Okay, then 80 divided by 40, that will be 2. Then 3200 divided by 40, of course, that will be 80. Yeah, 80. Okay, so that's equation 2. So now we know that because the acceleration is constant. So now why I said we cannot conclude here that because the distance is 1000 kilometers. Okay, now we need to understand that why I said S subscript 100 equals to S subscript 80 is because now we have the time between passing successive kilometers. So during the first kilometers, the distance is 1000 meters. For the first, then second kilometers, that will be another 1000. So that's what it means. Okay, so now so we now recognize that V2 equals to, now I can say but V2, okay, equals to V1 plus A times T1 in this case. So that V2 will be equals to, because I said the velocity at the end of, at the end of the first kilometer. So V2 will be equals to V1 plus A multiplied by 100. So that this will be V1 plus 100A equals to V2. So let's call this equation 3. That's our equation 3. So now I can then substitute. Yeah. So this is equation 1. Okay. So yes, let's do some substitution in this case. So now, so I can then say that from, now substitute, okay, substitute for V2 in equation 2. In equation 2. And we have equation 2 to be 25 equals to 2v2, okay, plus 80a. That's equation 2. So that 25 will be 2 multiplied by v1 plus 100a plus 80a. So that this will be 25 equals to 2v1 plus, this is 200 plus 80a. So that this will be 25 equals to 2v1 plus 280a. So let's call this equation 4. So now we have v1 in equation 1 and a. So now we should be able to solve for the value of a. All right. So from here we have equation 1. So we have equation 1, which is v1 plus 50a equals to 10. Then we have equation 2. Equation 4 rather. By using equation 4. Equation 4 is 2v1 plus 280a equals to 25. That's equation 4. Now, let's use substitution method. So I can say from equation 1, we have v1 to be equals to 10 minus 50a. So let me substitute for v1 in equation 4. That is this equation. So that will be 2 multiplied by 10 minus 50a, then plus 280a equals 25. So this will be 20 minus 100a plus 280a equals 25. So this will be 180. So this will be 20 plus 180a equals to 25. So we connect like terms. This will be 180a equals to 25 minus 20. This will be 180a equals to 5. So if I divide both sides, okay, by 180, so this will be 180a divided by 180, then 5 divided by 180. So that the value of a will be 5 here 1, 5 here 3, that's 15. We have a remainder of 3. Then so that will be 1 over 36 meters per second square. 1 over 36 meters per second square. That is the acceleration of the cyclist, okay, freewheeling down a long straight hill, okay, when the times between passing successive kilometers posts are 100 seconds and 80 seconds respectively. And we've come to the end of this tutorial. No less pleasure is the joy of understanding. Bye bye.